Okay, let's go ahead and take a look at some limits. So the first one here, limit as x approaches infinity of 1 minus e to the 1/2 minus 1 over x. The only place I see an x in the problem is this 1 over x. So I'm going to think about what the graph of 1 over x looks like. I know it looks like this, and that as x goes to infinity, I'm dividing 1 by a bigger and bigger and bigger number. So the graph is going to approach 0. So that means that this term here goes to 0. There's no x anywhere else in the limit, so everything else in the limit just stays, and that's our answer to our limit. Okay, the one on the right is a lot easier to evaluate if we think about rewriting it without the negative exponents. So if I rewrite it without the negative exponent, I get 4 over e to the x plus x over e to the x. So now when we go to infinity, we think about which part of our rational expression, the numerator or denominator, grows faster. Well, e to the x grows quite fast, so e to the x is going to grow faster than 4. So this first term would go to 0. Likewise, e to the x grows faster than x, so that term would also go to 0. So since our denominators increase at a much faster rate than the denominators, our limit is 0. Okay, next one. If we are looking at an expression that can be factored algebraically, often that's the best way to find the limit. If you were merely to plug in a 0 for all of the x's, you would get the indeterminate form 0 over 0. L'Hopital's rule can apply here, but it's a much shorter process to simply factor out a common factor of x to the 6th. That leaves us with 3x squared minus 4. And then in the denominator, also factor out an x to the 6th. After we factor out those common factors, they cancel. And if you look at the expression that remains, we can merely plug in a 0, leaving us with 3 times 0 minus 4 over 0 plus 7. So that simplifies to negative 4/7. Okay, now our expression on the right is a good indication that we're going to use L'Hopital's rule if we get an expression that has lots of different functions going on. I see some polynomial-looking terms. I see an exponential and cosine. So probably this is going to be L'Hopital's rule. First, very important, we're going to take the limit of the numerator alone as x approaches 0. So cosine of 0 is 1 minus 0 minus 1. That gives us 0. Take the limit as x approaches 0 of just the denominator. So e to the 0 power is 1 minus 0 minus 1. That also gives us 0. So what do we have is an indeterminate form, 0 over 0. And we're going to employ L'Hopital's rule. So up here, I'm going to say by LHOP, or by L'Hopital's rule, this limit is equal to the limit as x approaches 0. And now I'm going to take the derivative of the numerator and denominator. I'm not employing the quotient rule, just differentiating the numerator and denominator. So I get a negative 2 sine of 2x minus 5x to the 4th over e to the x minus 1. Let's mentally plug in and see if we now have a determinate form. Well, in the numerator, sine of 0 would be 0. I would also get a 0 here, so I have a 0 in the numerator. In the denominator, I have e to the 0 minus 1. So e to the 0 is 1 minus 1 is 0. So I have another indeterminate form. So, more work ahead. We're going to take the limit as x approaches 0 of the numerator. And we already know that that's 0. We just plugged in to check. Okay, let's take the limit as x approaches 0 of the denominator. Again, that's 1 minus 1, which does indeed give us 0. So we have, again, our indeterminate form of 0 over 0. Determinate. Okay, so I've justified the applicability of L'Hopital's rule. So I'm going to use LHOP again. Make sure that you rewrite limit as x approaches 0 each time. Okay, we are going to do chain rule again. And when I do chain rule again, I end up with -4 sine of 2x. And then back here using the power rule, 20x cubed. In the denominator, I have just left e to the x. Oh, and when I took my derivative of the numerator, I put the wrong expression. Let's go ahead and do that again. Okay, so in the numerator, I'm going to have -4 cosine 2x, that sounds better, minus 20x cubed. Sorry, I'm running out of room a little bit there. And then I have e to the x in the denominator. Okay, now let's see if we can plug in. I think we can. -4 cosine of 0 is 1, minus 20x cubed, plugging a 0, we get 0, divided by e to the 0, that's just 1. So L'Hopital's rule, when we apply it twice, works, and we end up with a limit of -4. Okay, watch the next video to see the rest of the problems.